Hi everyone. First of all, I would like to thank the entire organizing committee of FoodSim 2020 for facilitating the wonderful opportunity to interact with my audience through this web portal in spite of this crisis situation. And also, I would like to thank the chair of this session for creating an enjoyable environment. My name is Rajat and I'm a student in University College Dublin. Today I'm going to present our research work which is on quantitative risk assessment of E. coli O15787 on ready-to-eat foods following the application of biomaterials on land. Livestock contributes approximately 40% of the global value of agricultural products, providing livelihoods and food security for almost 1.3 billion people worldwide. The agri-food sector is one of the major contributors to the economic growth of Ireland. The Department of Agriculture, Food and the Marine has reported that the food and beverages sector accounts for 24% of all industry turnover in Ireland. The disposal of farmyard manure and slurry is a challenge because of the growing numbers of animals, the resulting increase in waste generation, and limited disposal options. EPA guideline recommends the most preferable hierarchy as minimize, reuse, recycling, energy recovery, and disposal of waste. Anaerobic digestion has been identified as a potential green technology to treat food and municipal waste and agriculture residues, including farmyard manure and slurry, to produce biogas. Also, AD holds the lowest environmental impact of all renewable energy. However, the feedstock of AD contain high levels of pathogens such as Clostridium, Campylobacter, Cryptosporidium, pathogenic E. coli, Listeria, Salmonella, etc. Though AD and pasteurization can inactivate a significant number of pathogens, complete inactivation is unlikely in the digestate. On one hand, farmyard manure and slurry and digestate can act as soil conditioners and provide valuable nutrients to plants. On the other, it may also contain harmful pathogens and pose potential human health concerns. The disease burden of these pathogens is huge. According to WHO, 0.5 billion foodborne disease incidents were recorded in 2017. 0.3 million people die annually, and the most vulnerable population is children under the age of 5. E. coli holds the biggest share of global disease burden. Health Service Executive Ireland prioritizes the pathogens of concerns as norovirus, pathogenic E. coli, Salmonella, and Cryptosporidium. E. coli normally live in the intestines of healthy people and warm-blooded animals. Most varieties of E. coli are harmless or cause relatively brief diarrhea. But a few strains such as E. coli O15787 can cause severe abdominal cramps, bloody diarrhea, and vomiting. We may be exposed to E. coli from contaminated water or food, especially raw vegetables, salads, and uncooked ground beef. Young children and older adults have a greater risk of developing a life-threatening kidney failure incident, which is called hemolytic uremic syndrome. Ireland has the highest incidence of these human verotoxin producing E. coli infection in the EU at almost 10 times the EU average. Therefore, the overall objective of this study was to create a quantitative microbial risk assessment model to assess the risks from E. coli O157 resulting from the application of digestate bovine feces and slurry to agricultural land and evaluate the resulting hazard loading in soil and assess potential intake through the consumption of ready-to-eat salads which are grown on the land. The material and method includes several steps of exposure assessment. It starts from initial pathogen count in the feedstock, and these pathogens can be inactivated by the mesophilic anaerobic digestion process, which I considered as 37-degree temperature. There is a potential log reduction can be achieved, which is 1.5 to 3.3 during this process, and this is followed by a pasteurization process where higher inactivation can be achieved up to 6 logs. This step was followed by an optional storage condition where the digestate is stored for at least 1 month. The inactivation value from the literature indicates that there can be a growth in the storage condition and the inactivation during the storage is not very high. When the digestate is applied on land, it undergoes dilution process. According to Longhurst et al., the pathogens can mix only in the top 300 mm of the soil layer. Therefore, there is a reduction of 0.477 log 10 due to this dilution process. This step was followed by a natural decay on land due to the presence of oxygen and light for the first time, then desiccation, UV ray and heat. Under these circumstances, the pathogens may undergo a huge number of reduction through a period of 60 days. Why 60 days? Mostly in Ireland, the majority of the digestate share is coming from the cattles. So I consider 21 days as a restriction period, followed by a crop growing time of spinach, which is approximately as 40 days. So approximately in total of 60 days were considered for this decay model. And when the crops are harvested, before packaging, it is cleaned by either water or mainly the chlorinated water in the industries. There, a significant removal or inactivation of pathogen happens. I only considered ready to eat salad for this research because if we heat our food, a huge log reduction happens up to 9 log. So therefore there is potentially very low risk associated with cooked food. And when the packet salads are stored on supermarkets in the cold storage, there is also a potential growth in the storage system through storage time. In Ireland, it's typically stored for 1 to 5 days. The potential growth constants are also collected from the published literature. Finally, the human exposure was calculated based on 0.35 grams of soil ingestion per day. According to Longhurst et al., average European consumes 35 grams of salads a day, and there is a potential chance of soil attachment through that salad, which is 0.35 grams. Therefore, the concentration final can be calculated as C initial minus log reduction due to mesophilic AD, pasteurization, storage, dilution, decay, chlorine treatment and potential growth on the shelves. And this C final can be used to calculate the human exposure. The daily probability of risk was calculated based on the beta Poisson dose response model available for E. coli 0157 from the literature. Here, a comparison between pathogenic E. coli and overall E. coli is presented in this figure, where E. coli dose response model is based on an exponential model. The infective dose ID50, which stands for the amount of pathogens responsible to cause 50% illness in our body, is presented also in this figure. So if we compare these two curves, you can easily say that E. coli 0157 is more harmful compared to the overall E. coli. The daily probability can be also converted to the annual probability with the equation 4, where the number of days of salad consumption is expressed as 365. So I have assumed that everybody is consuming salads all 365 days a year. This can be a worst case scenario model. The result shows a stepwise exposure assessment of the mean concentration of the organisms of E. coli 157 at different stages, where it started with a 6 log value and ended up with a minus 11.9 log 10 CFU per gram. The biggest drop can be seen in this figure as the log reduction due to pasteurization, where the concentration of E. coli 157 drops from 3.1 log 10 CFU per gram to minus 2.9 log 10 CFU per gram. A sensitivity analysis revealed that log reduction due to chlorine treatment is the most sensitive parameter of this model. The log reduction due to chlorine treatment is negatively correlated with the final risk, which means if we apply the chlorine treatment, the risk can be minimized. This is followed by the decay of E. coli on the land and the log reduction due to mesophilic AD. The initial concentration of E. coli 157 is positively correlated, which means if there is a higher concentration in the initial feedstock, there will be higher risk. The final risk from E. coli 157 is presented in this table, where several scenarios were conducted as pasteurized AD application or unpasteurized AD application or raw farmyard manure and slurry application. The highest human exposure of all scenarios is from the raw farmyard manure and slurry application, which is 3.85 into 10 to the power minus 2 CFU per day, followed by the unpasteurized AD as 2.68 into 10 to the power minus 4 CFU per day, and the lowest daily human exposure was observed for the pasteurized AD application, which is 2.72 into 10 to the power minus 10 CFU per day. Therefore, the P annual from the application of pasteurized AD was the smallest, which is 5.85 into 10 to the power minus 9, and the highest risk can be as a result of the application of raw farmyard manure and slurry, which is 1.4 into 10 to the power minus 1. These annual mean risks were compared with the WHO limit of risk, which is presented in the next table, where 10 to the power minus 6 is a representation of lower risk, and it is to be noted that this WHO limit of risk is based on the chemical risk assessment and the endpoint is the death. Therefore, a few studies indicated the low risk regime as 10 to the power minus 4 instead of 10 to the power minus 6. In comparison with the incidence in Ireland, we can say in 2017, 923 cases of VTEC E. coli were notified, whereas if we apply the annual probability of infection due to the use of pasteurized digestate on entire 4.9 million population of Ireland, it equates less than 1 person. Therefore, the risk from pasteurized digestate application is very low. Jumping into the conclusion, there is a very low risk involved in the application of pasteurized digestate, while unpasteurized digestate and raw farmyard manure and slurry pose a higher risk. The sensitivity analysis revealed that the inactivation effect of cleaning ready-to-eat salads with chlorine, decay on land, inactivation due to mesophilic AD, initial concentration of pathogenic E. coli, and the effect of storage influenced the QMRA model hugely in an order of high to low. This study highlights the importance of pasteurization as the remedial measure to ensure greater food safety. Thank you very much for your kind attention. I would like to acknowledge the financial support from the Department of Agriculture, Food and the Marine and UCD seed funding